There are several different data structures we can use to manage and store data in our program. We have stacks, queues, hash tables, trees, heaps, linked lists, and so forth. In this video, we're going to look at a linked list. A linked list is a type of data structure in computer programming. A linked list is a linear collection of data elements called nodes that are randomly stored in memory, where each node points to the next node. A linked list is dynamic, so that means that it can grow and shrink while the program is running. You can operate insertion and deletion anywhere in the linked list. A linked list is constructed using pointers, where each node points to the next node. Here we have a visual demonstration of how a linked list works. Usually the first node in your linked list is called the head node. Some people call it first node. Each node should contain two pieces of information. One piece of information should be the data. For example, if I'm putting names or numbers in my linked list. And the second portion should be a pointer pointing to another node. Usually we call the pointer that points to another node next or next pointer. And the last node in your linked list should always point to null, because you want the program, when it's executing, to know where or which is the last node in your list. So the last node always points to null. So now I'm going to head over to my IDE and write some algorithm to do some operation on a linked list. To construct a linked list, you can either use a class, but today I'm going to use a structure. So the first thing I want to do is create a structure called node. So I'm going to use the keyword struct and the name of my structure. So I'm going to name my structure node. Then inside of my structure, I want two pieces of data. I want an integer called data, and I want a node pointer that would point to my next node in the list. So I'm going to name this node next. And that's all you need inside of the structure to create a linked list. I'm going to declare my main function. So the first function I'm going to create is going to be a void function, and I'm going to call this function first node. And inside of my first node function, I want to take in a pointer. So I'm going to use the keyword struct and node, and I'm going to call this pointer head. Then I want to declare an integer called number. And the second function that I want to create would also be void, and I'm going to call this function add node. Instead of my add node function, I also want a head pointer, and I also want to take in a number. Let us define the first function. Inside of this function, I want the head, which I declared inside of the parameter list, and I want to take the data, what's inside of my node structure. And I want that data to equals to or to initialize to the number that is passed through the parameter list. Then I want to get the pointer, so it's going to be also head, and I want the next pointer to initialize to null. Because when we create the first node, automatically this node will point to null because there are nothing else in the list. The second function we're going to define is the add node function. Inside the add node function, we want to create a new node, which is going to add node into our linked list dynamically. And to do that, we're going to use the data type node, which we have declared at line number 5. That's the name of our structure. This variable is going to be a pointer, and we're going to name the variable new node. And we're going to initialize it to a new node that comes in. In order to add node inside of the linked list dynamically, we have to use the new keyword and the name of the structure, which is node. Then we want our newly created pointer variable new node and we want the data inside of that node initialized to the number that is passed through the parameter. We also want to take the next value inside of the new node we created, and we also want to initialize this value to null. Then we're going to create a different pointer node variable called current that will keep track of the node inside of our linked list. So we're also going to use the struct data type, which is node, and we want a pointer, and I'm going to name this variable cur, and I'm going to initialize our cur pointer variable to the head of the linked list. In order to add nodes into our linked list, there are some conditions we have to check. So we have to check while our current value is available. Then inside of the while loop, we have a next condition we have to check. So the condition we want to check is if the current value, their next pointer, is equals to null. So if the next value inside of our linked list is equal to null, then we want to add or append our newly node that we're entering into the linked list. So to do that, we can use current or our cur variable, and we want the next pointer equals to the new node. And after we set the newly created null to the next pointer, then we're going to return to the function. Else, if it's not equals to null, we want to go through the list until we find the last node in the linked list that is initialized to null to add our new node in the list. So to do that, we want the current pointer or the cur pointer to initialize to cur next. And let's create a function to print the values in our linked list. So this function will be void, and I'm going to name this function print. And inside of my print function parameter, I want to declare a struct pointer, so a node pointer called number. So inside of the print function, we have to check a condition before we start printing the value. So we're going to use the while loop, and our condition will be while the number is not equals to null. We want to print the data. And to do that, let's just use the classic cout statement, and we want the number and the data inside of that newly created structure node. And we want to initialize the number to number next. So this line of code will be going through the linked list and printing the numbers as long as the number is not equal to null, or as long as it's not at the end of the list. So inside of our main function, let us create a node pointer. So we're going to use the keyword struct, and we're going to name this pointer head, and it's going to equals to a new node because we are going to get in the numbers dynamically. Now let's call the first node function to insert the head into the linked list. Instead of the first node parameter, we want the head pointer, and we want to add the number 10 to our list. And then let us call the add node function. And inside of the add node function, we also want the head pointer and the number we want to add into the list. So let us copy this line of code at line 47, and let us paste it several times. So in here, we want to add 10, 20, let's add 30, 40, 50, 60, and 70. And now let us call the print function, and let us print the head node. So let us build and run the project. And you see, we get the numbers that were just inputted.